Welcome to Stars Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to Stars Launch Pod, space, technology, and research sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise. And it's a great honor to have Brian Campbell with us on the show today, NASA Senior Earth Science Specialist and Outreach Manager with GST. Welcome to the program.
Hi, thank you, Susan. Thank you for the opportunity to be here.
Well, it's truly an honor. We'd like to hear a little bit more about you as we get started.
Sure. Yeah. So, as you mentioned, I'm a NASA Senior Earth Science Specialist and Outreach Manager with GST. And I'm in my 25th year as a NASA contractor, and I work in the earth sciences. So, I do a little bit of everything. I've been working with NASA Earth observing missions my entire career, and I do a combination of, looking at the science, interpreting the science, working with students from literally around the entire planet, working with educators from around the world and researchers around the world, and helping them better understand what our satellites and instruments and data are telling us about our planet.
Right now is a very exciting time. There's a lot of things going on out there.
Yeah. There's our planet is dynamic, so we see things happening all the time. I'm currently looking out my window and I see the clouds moving rapidly past us. I see the skies blue in one spot and dark in another spot. Things are changing all the time. And, working with students and educators and researchers around the world, it's important for us to know what's happening locally so we can understand how things are happening globally.
Exactly. What are you currently working on to, maybe further the space industry?
Yeah, so I work on, as I mentioned, Earth observing missions. So one of the missions I work on now, I'm on the ICESat satellite team, and that's the Ice Cloud and Land Elevation Satellite 2. And that is a laser altimeter in space. So basically what it is it's a satellite that was launched on September 15th, 2018. So the 15th of September, 2025, 7 years in space of basically firing laser pulses at the planet 10,000 times per second to measure the height of objects on Earth. So we really focus on the polar regions. We're focusing on how the polar regions, how the ice elevation is changing over time. But we're also able to see how the third dimension on the planet is changing, how the height of everything from the ice to bodies of water like the oceans and rivers and lakes and reservoirs, and even trees. Tree height is changing and vegetation. And we're seeing how this is changing because all of these things are dynamic. So the ICESat-2 mission has fired over 2 trillion laser shots over the last just under 7 years, and we've gotten a great amount of data from that. So one of my jobs is to help, change our perspective and understanding is to get people to understand what all this data means, because that's a lot of data. We're getting over a terabyte of data a day from just this one satellite, ICESat-2.
Are you
So
learning about maybe ice melting and how that's affecting and the temperature of the Earth, or perhaps entire tree die-offs or something along those lines?
yeah. So we're really focused on the 2 major ice sheets on Earth. One is Greenland and one is Antarctica. And we're seeing melting in those areas, certain areas on those 2 ice sheets. So we're really trying to understand why there's certain areas melting so fast. And the satellite allows us to see changes down to just a few centimeters. If we have ice that melts even 2 centimeters, we're able to see that with the ICESat-2 satellite. But then, we're also being able to determine where the trees are with ICESat-2, and then also knowing where the trees are and getting the tree height from space of trees on Earth, which is a crazy concept to think of. We've mapped the height of several 100 billion trees so far on the planet. There are about 3 trillion trees on Earth, so we haven't gotten them all yet, because that's a lot of trees to measure. And sometimes these things called clouds in the atmosphere get in the way of the lasers. So,
Right.
our satellite has a love-hate relationship with clouds. We do measure cloud heights as well because it's in the name,
Mhm.
ice cloud and land elevation satellite too. But sometimes they get in the way when we're over a large area of trees and a forest. Sometimes the clouds block out the laser light. But yeah, but knowing the tree height of all these trees across the planet helps us understand the amount of carbon trees have been pulling in, from the atmosphere over time. So yeah, so we're looking at how things are changing over time. We're looking at, basically the change in this third dimension, everything from ice all the way down to vegetation.
Been your biggest aha moment?
So going back to working with students and educators, I work with a program called the GLOBE program, and it stands for Global Learning and Observations to Benefit the Environment. And it's primarily a NASA funded program. And right now, this year, it's 30 years. It's been 30 years since the program started, and it's active in 127 countries. And what's really cool about it is that the students basically take observations in their local environment and share it with the rest of the world through the Globe database, through student research projects, through field campaigns. And the one thing I really think is cool is that we've been working with students as folks at NASA and beyond, but when they take their observations, the aha moment is for me is when they're taking observations and then they're talking to us, who are seeing the data from satellites, but we see the data that they're taking, and then they realize that every single measurement that they take makes a difference because that data, for instance, if they're out there taking tree height data from the ground,
Mhm.
they're potentially taking data that the satellite has not taken. So that's extra data for researchers, student and professionals alike. But also, if ISAT-2 has taken that data, it is complementary data that can be compared to the satellite data that researchers can then use to help compare the ground-based data from the students and educators to the space-based data from the satellite. And the students then become a huge part of a much larger mission to help understand our planet just a little bit better.
Bet they get really excited knowing that they are actually a part of it and they're helping move everything forward.
Oh, they do for sure. Yeah. Students, they love it. And it doesn't matter what country they're from, And and when I say that because I see when I've traveled different parts of the world, I get so excited when I see a child, no matter what age, even adults as well, wearing like a NASA t-shirt.
Yeah.
And I'm like, wow, this is so cool. I was in Slovenia several years ago at a forest conference, and I was there for NASA presenting, doing things, working with educators and some students out in the field. And as I was walking through downtown Slovenia on my day off right before I flew home to the United States, I saw two students walking and they both had NASA t-shirts on. And I was like, wow, this is amazing. And I had my NASA jacket on and they stopped me and they said, where did you get that jacket? And I said, I actually worked there in the United States. And you would have thought they met a Hollywood actor. And it was the coolest thing. And I said, I'm one of many who worked there. So we got to talking and they were interested. They were going to a local university. They were in a STEM program at the university, which I thought was great. And I told him, I said, you know, thank you for wearing the NASA shirt, and you guys are the future, and you're the ones that I love working with all the time. So yeah, it was really cool to see.
Hang on a second, Brian. Hang on. Hang I had to get this because you're a rock star.
That's awesome.
See?
I love that NASA logo the best, better than the meatball. I love the worm
Oh,
logo.
this one right
Yes,
here.
That's always been my favorite.
Lots of
Yep,
patches, lots of fun stuff, lots of
yep,
missions.
yep.
Yes, it's
HoloLens.
and it I can imagine how that made you feel. So I had to, you know,
Yeah, that's
show
cool.
you I
Yep.
was
I
on
like that.
board.
I like the color of the jacket because that's like like the original color, the light blue.
Yes, this is a very old jacket.
Yeah, I like that. Yeah.
Um, Back to our questions. I'd like to know what has been your biggest challenge during this time and how did you overcome it?
Yeah, there's been a lot of challenges, and you know, I think some of the challenge is there's so much data out there. And working in the NASA Earth Sciences and working, since I work with a lot of students and educators, we want to provide them with the best data possible and be able to get it. There's so many different ways to get NASA data. There's lots of online tools.
Mhm.
There's lots of, different methods to get it. There's tons of visualizations and videos where it's just overwhelming. And there are students from around the world who do research projects every year, whether it's through the GLOW program or their local schools or K through 12 schools or universities. But they want to do a research project and they want to use NASA data, but they get overwhelmed. And even I, in my 25th year at NASA, I get overwhelmed because I want to go find, for instance, some soil moisture data. I used to work on a mission called SMAP, Soil Moisture Active Passive. It's still in space. This is its 10th year in space. It was launched in January of 2015. And when I go and I look for the SMAP data, when I look at it on something called NASA Worldview, it's great. But when you look at it, there are like 12 different types of data sets that you can look at. And I look at it, I'm like, oh, which one do I go to? And I know all these data sets pretty well. And then, but I could imagine, what someone just going there for the first time as a student who's not well versed in this data, or an educator who's not well versed in this data does. So, one of the biggest challenges is distilling this literally probably trillions and trillions of points of data
Mhm.
to get it to where and what the students and educators need for their purposes. Because, as I mentioned, I've worked on lots of missions. I've worked on the ICESat. Of course, I'm working on ICESat 2. I've worked on ICESat 1. We just called it ICESat, but to refer to it now, we just call it ICESat 1. I've worked on the SMAP mission. I've done some Landsat work, the GPM mission, lots of different missions over time. And all that data is still out there, archived. Some of those missions aren't taking data anymore. Some of them are decommissioned. Some aren't in space anymore. But that data is still there and it's valuable data to be used. But it's a lot out there. So that's one of the hardest parts when someone comes to me and say, hey, can you provide some land data from 2002? And then I
Mhm.
go back to 2002 and I see literally billions of data points. And I'm like, whoa, I think that's
Somebody
one
needs
of,
to get in there and organize it.
yeah. I mean, there are all those online tools have it organized really well, but when you go to it, I guess you really have to figure
Know
out,
what you're looking for
yeah,
and
what you're looking for and really
right.
take some time. That's one of the things because NASA, we're a science agency, so we have lots and lots of data out there, and it's in great places, and the online tools are very valuable and
Mhm.
well put together. It's just there's a lot of data out there because we have so many missions doing so many good things.
Brian, what would be what piece of advice you'd like to share with our listeners?
So one thing I always like to tell people, and it's kind of, I don't know, it's you hear it in different ways from different groups over time, even NASA, but I always like to tell people, and this goes back to um, back in 2017, I uh, I was inducted into my high school's academic hall of fame in Pennsylvania, and I gave an acceptance speech. And you often hear failure is not an option at NASA. Okay. And that's totally understandable. But personally, I always like to say, for me, failure was an option because I think failing at things makes us better at things. Because I failed a lot in my life, in order to get to where I am. And when I say that, I know failure brings people down, but there's been lots of times when I've written research papers and submitted them. They got turned down. They said, "Oh, you need to rewrite this because it's terrible." And then I got it back and rewrote it, sent it back, and they said, "No, not good enough. You need to like do more." And then I resent it back again and again. And finally, after like 5 or 6 or 7 iterations, it finally got approved. And that's, really disheartening, thinking like, oh, you have a great paper here. There's been times when I've written proposals to have something funded, and they're like, nope. So I thought I wrote a great proposal, and they're like, nope, try again next year. That type of thing.
I always say it's an
And
opportunity to grow and learn.
yeah, it's an
So,
opportunity
yeah.
to grow and learn. Yeah. So if you fail at something, just don't get down. If you fail multiple times, same thing. It's just one of those things that happens in life. All of us fail at some point in life. It's just a way to, like you said, to learn from, grow from, and just it helps you get to the next level.
Before we wrap up, do you have a passion project, maybe past or present, that you'd like to talk about?
Um, yeah,
I'm guessing it has a lot to do with the students.
it does. When I start working out with students when they're, around the even elementary to middle school age,
Mhm.
and they show an interest in the science. My son, he's 18 now. He has a great love of music. He doesn't have a great love of math and science. My wife is a math teacher, a math coach, and a mathematician. My son isn't big into math. He's taking pre-calculus now in high school, and I'm into the science, right?
Mhm.
He's not. He's big into music and music theory and all that. He can apply some math and science into that. Okay, but we brought him into early in math and science, and but he didn't go the route. But what I'm thinking is when I really really see this interest in students from anywhere around the world, and it's usually within the Globe program, like when I'm working with students online from different countries, helping them, mentoring them with student research projects, whether it be something related to one of the satellites I work with or just some of the earth science data, working one-on-one with them and their teachers to try to figure out a research project and then see it come to fruition. An example of a really cool one that I helped see through was I was working with a group of students in Croatia, and they were working to basically find out what was going on in a local park. So they came to me really early on and said, "Hey, there's some issues going on with this park, that people are having some weird respiratory distress in this park, and that we're going to go do some air quality studies there." And I said, "Okay, that sounds good. Well, there's some globe measurement protocols you can use." And I was running a campaign at the time, a globe campaign at the time, which wasn't really looking into that, but there were other protocols. And when I say protocols, they're just environmental measurements, basically outdoor activities or lab measurements that you can take, like air quality and air temperature and surface temperature and soil moisture, all these different things. So they started taking these air quality measurements, and they started getting these really bad numbers for air quality. So they went further and further into it. They did more research, and they started working with some local environmental folks in this town in Croatia. And then they found out that what was happening was there was an invasive species of plant that was releasing these spores into the atmosphere.
Ooh,
And these spores were causing people to basically, it was getting into their lungs. It was causing their lungs to basically constrict, and they
wow.
were coughing. Nobody was
Yeah.
seriously injured, but it was just causing a little bit of respiratory distress. People were coughing and everything like that. So um, they went and they talked to the local people there, and they found out what exactly it was. And then it was mitigated by the folks from the town going in and eradicating all of this species. And then they went later on and did the air quality study again, and turned out perfect. The numbers were way up, and they helped out. So those are kind of my passion studies, where the students come up with an idea because they see some type of local issue
Mhm.
happening or going on, and then I never want to take credit for anything they do, but I like the idea of when they come to me and say, "Hey, check this out. This is a cool idea." And I just say, "Yeah, that sounds really cool." And they can come to me whenever they want. And then they take it to the next step, and then they figure it out, then they figure it out. And then I just feel proud to be even just the smallest part of that. And it's happened through lots of different
Yeah.
activities, whether it be at Globe or, just some students visiting over time who come back and repeat visit, like at the NASA Wallops Flight Facility Visitor Center here. They come
Gotta
back
be
each.
very
So
gratifying for you, I
yeah,
think.
yeah.
And speaking of Wallops, you were recently awarded the NASA Wallops Flight Facility Award, a very high honor just this past year, right?
I was, yeah, it was the Public Service Award, so that was pretty cool, and I found out it's,
Yeah.
like, highest award that NASA Wallops gives, so I was excited. Yep, I was awarded that December of last year. So,
Right.
yeah, that was really cool to receive.
All right, very nice. Brian, thank you so much for sharing your story with us here on LaunchPod. Loved having you as a guest. Really do appreciate it. It's
Thank you,
Brian
Susan.
Campbell, NASA Senior Earth Science Specialist and Outreach Manager with GST. Thank you again. Be sure to join us where we connect, collaborate, and accelerate. We'd like to invite you to join starsciences.org and receive a free one-year membership. Just put in the promo code FRIENDS321. And if you enjoyed this episode, leave us a review and subscribe. And until next time, keep looking up.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.